again, and let's go to part 2 of the ESP project here. Just making the board a little bit simpler to use in the last little while. Still handy to use the jumper cables over to a breadboard right now until I get some of the other things mounted, like that little 4-channel level shifter is going to go down there. The reason why I'm using 4 channels, it handles the serial pins, plus it handles the reset, and I believe it's the DTR pin. Can also pass over that, and that allows programming of that little ESP module to be just like it was an Arduino Nano or Uno. The actual IDE can reset it and load the software and then allow it to boot back into the normal running. And I've had a little page going here. Just in the bottom I've got real term showing its last message before I disconnected it. And then that page there has now been running for about 30 minutes, and it's just refreshing SVG graphic from a link on the web. And again, this is the included or the example file. I just made a few changes so I remember it's for my 12E. Other than that, all I did was change the refresh time to 10 seconds instead of 5, and just really didn't expect it to work actually quite as easily as it did. It worked really quite well, and again, that's the page right there, and here we have the level shifter. I'm not sure if this is going to focus in on it. Yeah, sort of, but you know, just a 4-channel level shifter. You can get them from eBay. This one came from Alice, I believe. I know they're available from SparkFun, but I think they're red. The board is red on SparkFun. I don't know if you saw the LED flash there. The sample code that they have flashes the LED whenever the page updates, which is every 10 seconds. And over on the left, you can actually see, I don't know if that'll come into focus there, the USB to UART adapter has a jumper wire through it, and that's what's giving me my I believe it's the RTS pin, which does the resetting over here, and then that goes actually through the level converter. Both those, the DTR and reset, go through that and then over to the appropriate pins here. Now you do need to use, if you're using that breakout board, to set it up to use the Arduino IDE for ESP, you are going to need 2 10K resistors to make it all run smoothly and stably, to get those 2 extra pins running. I've been quite pleased with that little buck converter in there. See if we can get that to focus. It has done the job pretty good. It stays pretty much at 3.299 volts, pretty much no matter what I throw at it as far as the draw. I've hooked a few other things up to test the ESP, but it's worked pretty well. So hopefully this stays in focus here. As you can see, all I've got is a simple power button there, and the power input blocks there, taking about 13.5 volts there right now, and then the buck converter stepping that down to about 3.3. And the nice thing about using that level shifter is it allows the power supplies to be completely separate. Now I have noticed there's a tiny bit of back powering. If I was to unplug that USB adapter, USB serial adapter on the left there, you would actually see some of its LEDs stay faintly lit, so there is some power going back up through that level shifter back into that. Oops, sorry about the shake there. Don't really have a tripod for this one, I'm just sitting on the couch. But again, let's see if this will catch that. I'm just using the newer Arduino IDE, and I've just downloaded the updated board manager and just grabbed the ESP boards package and installed it, and it worked great. I did set the LED on some of the examples to be pin 13, which matches my GPIO 13 on my ESP12. And other than that, it's been working pretty good. So my next video, I'm probably going to have a test of the ULN 2003, because it's supposed to trigger at 2 volts. So it would be nice to get the level shifter down here and a ULN 2003, which would allow me to run some heavier inductance loads because it's a Darlington array. And it also has a freewheeling diode in there to protect from, for example, spinning a motor and then having it, well, run on or freewheel. The other thing I thought of doing was maybe daisy chaining some shift registers off it, which would allow for output only. Although my immediate use is actually simply detect the lock state and state of a door, so that's only going to use 2 GPIO pins for detecting the doors in a lock state. So I'll have a little bit left over. I mean, we'll have a look and see what else I might get into. I might actually put the I2C bus based 2-line text display. That might be a good thing to have on that, so I can possibly have a couple buttons to get it to show me current IP and all that jazz, and possibly the door access history without having to go to the web page. Not exactly sure there. Another thing that I need to do shortly, and it'll be upcoming, is an app that I've been using on my Samsung phone, which is what I film most of my videos with, is my Samsung Alpha. And I have to get my wife to use her Samsung Alpha to film my phone, connected using a terminal program. The on-the-go cable, or the on-go programming port, allows me to actually use an Arduino programming from my phone, but it also gives me a great little serial terminal in my cell phone, which essentially turns my cell phone into a debug display for pretty much any one of my Android devices. And I'm going to want to try that on the ESP here later, but that'll be for another video. But again, that's the update, and as always, thanks for watching.